Good morning. I am Vedaraj, Associate Professor, Department of Computer Science and Engineering, RMD Engineering College. In this session, we are going to discuss logical clock in distributed system. What is logical clock? Logical clock are based on capturing the chronological and causal relationship of processes and ordering events based on this relationship. As you know, there are three different types of logical clocks are maintained in distributed system. One is the scalar clock, the second one is the vector clock, the third one is the matrix clocks. Today we are going to discuss scalar clock. What do you mean by scalar clock? A scalar time is designed by Lamport to synchronize all the events in distributed system. A Lamport logical clock is an incrementing counter maintained in every process. When a process receives a message, it resynchronizes its logical clock with that sender maintaining causal relationship. Now we are going to see Lamport algorithm for scalar clock. See, four important rules we are going to discuss. The first important rule, all the process counters start with value 0. Initially, P1 have counter value 0, P2 have counter value 0, P3 have counter value 0. All the process counters start with value 0. The second important rule, a process increments its counter for each event. It may be an internal event, it may be a message sending event, or it may be a message receiving event. Whenever it sends a message, it increments its counter value by 1. Whenever it receives a message, it increments its counter value. Whenever internal event are happen, it increments its counter value. The third rule, when a process sends a message, it includes its incremented counter value with the message. Okay, the next rule, the final rule, whenever a process receives a message, the counter value is updated by maximum of receiver counter, comma, message timestamp plus 1. This is the four important rules of Lamport algorithm for Lamport algorithm for scalar clock. See, in this algorithm, initially P1, P2, P3 have counter value as 0. Okay, whenever the internal event is occur, the counter value is incremented by 1. So P1 counter value is 1. Whenever it sends a message, the counter value is incremented by, already the P1 counter value is 1. It is incremented by 1. So now the P1 counter value is updated as 2. Whenever it's sending a message, it sends a message along with the updated counter value. The updated counter value is 2. Okay, whenever the P2 receive a message, it updates its counter value maximum of receiver counter, comma, message timestamp plus 1. See, the receiver counter value is 1. The sender counter value is 2. Which one is maximum? The sender counter value 2. 2 plus 1, 3. 3 is updated as the P2 counter value. Thank you.